Quadrilaterals, Section 5, Video 2. Here we have some examples where we're given some parallelograms and then it tells us certain properties to be true. We need to then conclude what sort of more specific parallelogram do we have. So we're using what we learned about proving parallelograms and proving rectangles and proving a rhombus from the previous page, and we're applying it to some of these examples. So looking at example 1, I'm initially going to draw this so it's a little more clear. So we have a parallelogram A, B, C, D. So I'm going to label A, B, C, and D. And it has diagonals AC and BD intersecting at this point P in the middle. Determine whether the figure is a rhombus, rectangle, or neither, given these certain properties. So A says AC is equal to BD. So if I was going to label AC is that diagonal, and BD is the other diagonal. Okay, so it's saying that those are equal. What does that tell us? Well, if we go back to the previous page, we see that if diagonals are equal, we know that it is a rectangle. And so if I was going to draw it more accurately, I would draw it with the 4 right angles and whatnot. But I just drew a basic parallelogram just to kind of get a picture of what it is, and I guessed what those angle measures were. And I was obviously, visually, I was wrong in how I drew it. But since I know that those diagonals are equal, I know that it must be a rectangle. So the next example part says AB equals BC. So that's to say that AB, this length right here, is equal to BC. So that's saying that those are adjacent sides are equal. Therefore, I can conclude that I have, in fact, a rhombus. Because that is one of the properties of a rhombus, is that adjacent sides are the same length. Because I know it's a parallelogram, and so I know that opposite sides have to be equal, and therefore that would conclude that that's a rhombus. The third part says BP equals DP. So if I was going to grab one more color here, it's saying that BP, so this half little part, is equal to DP. So this part right here. So it's saying this length is the same as this length. So that means that at least one of the diagonals is bisected by the other diagonal. Well, I see that if both diagonals bisect each other, I know it's a parallelogram, but we already know this is a parallelogram, so we don't quite have enough information to prove anything else, so we would just say it's neither. Because that's not really a property for a rectangle or a rhombus. Moving on to the next example. We're given a new parallelogram, PRST. So once again, I'm just going to kind of sketch a basic parallelogram to get a better picture. P, R, S, and T. And determine if the following conditions give us a rectangle, rhombus, or a square. So PS equals RT. So that's these diagonals. PS is the same length as the other diagonal, RT. So that's to say that diagonals are equal, which if we look at our properties, we know that diagonals are equal if it's a rectangle. So since both diagonals are equal, we can conclude and prove that it is in fact a rectangle by the properties of a rectangle for writing a proof. The next part says PS is perpendicular to RT. So if we know that fact, that would mean that these diagonals, they form a right angle right here. Obviously the picture doesn't really show that, but imagine it did. So that's to say that the diagonals are perpendicular, and we know by the properties of a rhombus that that proves that this parallelogram would in fact be a rhombus. And this third part says that both those things are true. So we know PS is equal to RT, and we know that they're perpendicular. So therefore, that way we know from our previous two ones, we know it's a rectangle as well as a square. As well as a rhombus, which I kind of gave it away. If something's a rectangle, so that means it has 4 right angles, and something is a rhombus, which means it has 4 congruent sides, we know it must be a square. So if I didn't have A and B there, I would have written, I know a diagonals are equal, tells me it's a rectangle. I know it's perpendicular, which tells me it's a rhombus. If it's a rectangle and a rhombus, I know it must be a square. And our last examples here are just a little different way to ask the same questions. So once more, I'm going to draw my parallelogram. L, M, N, P, and these will look very familiar. It's just a different way of asking the questions. So it's saying that if Ln, that diagonal, is perpendicular to MP, then Ln NP is a rhombus, which we know that if the diagonals are perpendicular, then we have a rhombus. We did that earlier, so that's true. If Ln equals MP, so those are, this length is the same as this length, we know that the diagonals are equal, which tells us that it's a rectangle, so we know that to be true. And if both of those things are true, if it's perpendicular and equal, we know it's a rectangle and a rhombus, which would tell us that it is in fact a square. So those are the same forms of logic, same properties used, just a different way to ask the questions in a true-false way.